Okie dokie. So in this video, we're going to look at complex numbers in the complex plane. So you're probably real familiar with the regular number line. It just goes left and right, and it goes forever. It's a pretty good system, and it's carried you to all the negatives way out here, and it's carried to all of the positives and all the fractions and irrational numbers and like pi and e and awesome numbers. Really good stuff. But it turns out you have been missing most of the numbers. So the complex plane is like the real number line. It still has the real number line included. It basically is kind of like the x-axis, and you're going to see this behaves just like the x and y-axis, except on the complex plane, this is your real number line, so your real part, and the y is actually your imaginary part or the complex part. So this is the format for all complex numbers. It's always something plus or minus some imaginary part. So when the complex part, when the b is equal to 0, you just wind up with a number on the real number line, or basically on a real number line. When the real part is 0, you wind up with something that's just on the imaginary line. So like 2i. And that's how you represent these in the complex plane. But they're going to act just like ordered pairs, parentheses x comma y. All right. So let's look at, say, this number here. All right. That number would be the number 5 plus 2i. All right, because it's 5 for the real part, and then it's got 2i, or 2 parts for the imaginary part. So you just go, over 5 and then up 2. It's a lot like it. This would be negative 3 minus 4i. All right, just circle that and kind of draw an arrow up to it. There we go. But the advantage that you have with, complex numbers, that's what these are called, is that you can actually do stuff with them. You can multiply them, divide them, add them, subtract them. You can't really do that with ordered pairs, with just plotting points and stuff. Then this one here, this would be the number 6, that's the real part, minus 7i. Okay, now what I want to do next is look at the absolute value of a complex number. All right, and they have this nice little formula for it. The absolute value of a complex number is a squared, so you take the real part and square it, plus b squared, so you're forgetting about the I, and then you square root that, right? But what does the absolute value of something mean? Like if I had asked you to find the absolute value of negative 2, you know that's equal to 2. All right, you just make it positive. Or the absolute value of 3 would be 3. But what it actually means is its distance away from 0. So negative 2 has a distance from 0 of 2. Or the number 3 has a distance away from 0 of 3. And that's why distance is always positive. The absolute value is always positive. We're going to do something similar with this. We're going to find each of these numbers, probably just a couple of them. We're going to find their distance away from 0. So from the origin, or 0 plus 0i. So we're going to find that distance right there. And hopefully you see that this, if you kind of draw it straight down, you end up with a right triangle here. And because it's a right triangle, we can use the Pythagorean theorem to figure out the actual distance of this hypotenuse here. That's where the a squared plus b squared comes from. So for this number, 5 plus 2i, I'll call this my, I'm not going to label it, I'm just going to call it 2, because it's 2 units up. And this distance here is 5. And so you just apply the Pythagorean theorem to it. It's 2 squared plus 5 squared is equal to c squared. 2 squared is equal to 4. 5 squared is equal to 25. And then, this is 29. But then you have to square root it. And so you end up with c is equal to the square root of 29. All right. So that distance away from the origin is the square root of 29. Or with a calculator, we can actually find that out. Square root of 29 is 5.38516, and that is that distance. It's a little bit over 5. Okay, and that's why they get this formula over here. We just took 2 squared and 5 squared, we added them up, and then square rooted them. So you can do it with the triangle if you want to do it that way. So like if I was doing this one, it'd be right there. That distance is what we're after. Now we have 2 options. Yeah, we have 2 options for the way we build our triangle. We could go towards the y-axis, or the imaginary axis, or we can draw it up again to the real axis. And then your units, this one would have a distance of 3. This one would have a distance of 4. Let's just go ahead and use this formula, though. All right, so if we're finding the absolute value of -3 minus 4i, I didn't put that up here, did I? For this one, that was the absolute value of 5 plus 2i. Yeah. So we're going to do a squared, which this is our a, the -3. So that's going to be -3 squared plus b squared, which is the -4. And see, the negatives won't matter here because when you square them, they become positive. Okay, -3 squared is equal to 9. 4 squared is equal to 16. 9 plus 16 is equal to 25. And that's equal to 5. Okay? I guess we can do it real fast. If we wanted to find this distance, that distance there, we would need to do the absolute value of 6 minus 7i, which is going to be the square root of a squared, which is 36, plus b squared, which is -7 times -7. So that's 49. Notice this is always positive. 36 and 49, that's 85. So you get the square root of 85, which is like 9 point something. And that makes sense, 9 point something. Good.